Hello, this is Mr. Precella. I'm continuing to work on the final exam review sheet for my Math 1324 face-to-face class, and I'm going to do problem 19 right now. This is some financial math problem. A woman wants to retire in 8 years. At that time, she wants to be able to withdraw $12,500 at the end of each 6 months for 15 years. Assume that money can be deposited at 6% per year compounded semi-annually. What exact amount will the woman need in 8 years? Okay, so I'm going to draw a timeline. So a woman wants to retire in 8 years. At that time, she wants to withdraw $12,500 at the end of each 6 months for 15 years. Okay. End of each. So this is semi-annually for 15 years. Assume that money can be deposited at 6% compounded semi-annually. What exact amount will this woman need in 8 years? Well, if we look at this timeline, there's 3 places. She wants to retire in 8 years. There's the 8-year period. At that point, she's retiring right here. Okay? And she's going to be withdrawing $12,500 semi-annually for 15 years. We assume at the end of those 15 years, she's going to have no money left in that account. This problem really doesn't need this 8 years. The 8 years isn't going to come into play anywhere. This would have been the same problem if it had said a woman wants to retire today. How much does she need today in order to withdraw $12,500 semi-annually for 15 years? So this, when we're looking at this part of the timeline, the future value of the account is 0, so what we're trying to find is the present value. Now, hopefully you've got the hang of, or you remember how we were doing these back mid-semester. I always ask myself, is this an annuity? Is there a series of equal periodic payments? And the answer is yes. So what we have here is the present value of an ordinary annuity. Here's the annuity formulas that you need, and we're looking at present value of an ordinary annuity. That's also the formula you would use to calculate a house payment or a car payment, any sort of loan where you're amortizing it. So let me write it down. P equals R times 1 minus 1 plus I to the negative n all over I. Now P, that's what we're trying to find. So let me identify my unknowns. P, or the variables. P is what we're trying to find. R is the amount of the periodic payment. R is $12,500. I is the interest rate per period. To get I, we normally divide 6% compounded semi-annually would be 3%. To get N, we normally multiply. Well, how many total periods are there? How many semi-annual periods over 15 years? Well, it's 2 per year for 15 years, so 30 semi-annual periods during those 15 years. So now we'll plug in P equals R times 1 minus, now the 1 plus I I'll just do in my head. 1 plus 0.03 is 1.03 to the negative n all over I. Let me see. Did I bring a calculator? Let's see. Here it is. Oh, a bit of a glare. I'm punching in. I'll do this the way I always did it during class. I'll punch in the bracket number first, and then the multiply by 12,500. So punching in the bracket number. 1 minus 1.03 raised to the negative 30th divided by 0.03 times 12,500. So 245,005 and would y'all round that to 52 cents? On some of these we might be a few cents off because the test software is calculating those negative exponents differently. 245 right there, D. Okay, that was number 19. Now, number 20. Here we are using the elementary row operations. We start with this matrix. 5, negative 6, 7, 4, 3, negative 2. If we're going to write this matrix in reduced echelon form, first thing we need is a 1 right here. So how would we get a 1 there? And that's what it's saying here. You need a 1 there. Well, you can either say row 1 divided by 5 or multiply by 1/5. But the significant thing is you're just going to divide by 5 here. So that would get you a 1 there, a negative 6/5 there, a 7/5. All you need to know is that entry. So negative 6/5. Let's see. Number 21. Okay, well on this one it looks like they already have a 1 there. So once you get a 1 in that first position, you need to zero out that column, which is what they're doing. There's a 1 here, so they're going to leave that row alone and get a 0 down here. So this is problem 21. Let me write it down. 1, 5/3, 7/3, 2, 2, negative 1. Okay, so here's your 1. We want a 0 there. In order to get a 0, can y'all see better? In order to get a 0 where this 2 is right here, we're going to need to multiply this 1 by negative 2. If we multiplied that 1 by negative 2, that would give me a negative 2 there. Then plus row 2 is a new row 2. So we're keeping row 1 as it is. And that's what it looks like right here. Row 1 stays the same. Negative 2 times 1 is negative 2 plus 2 is 0. Now, here's the next entry is the one that we need. So I'm going to write out the operation. It would be negative 2 times 5/3 plus this 2 here. I'm writing that as 2 over 1 because I'm about to get a common denominator. This would be a negative 10 over 3 plus, how would I write that 2 over 1 with the denominator of 3? Well, 1 goes into 3 times. 2 times 3 is 6. To add two fractions that have the same denominator, you keep that denominator and you add the negative 10 plus 6. That's a negative 4. So negative 4/3 is the number there. If you wanted to check and verify that you have the right operation, what you could do is negative 2 times 7/3 plus a negative 1. We're told it's going to be a negative 17 over 3. Y'all do that? Either in your head or in a calculator maybe? Let me see. I'm just going to verify that we're getting a negative 17/3 there. If I did, negative 2 times 7 over 3 plus a negative 2 times 7 over 3 plus a negative 1. There's the decimal number. Math, enter. Can y'all see that? Oh, the glare is sort of bad. Negative 17/3. So if you don't want to get this, if you don't want to do this by hand, the little calculation, you can use your calculator if you want. But it's certainly not hard. Multiplying fractions, getting a common denominator. Okay? So, any questions? That's 19 through 21. Let's take another little break right now. Thanks for listening and watching.